So in this video, we're going to look at everything you need to know about completing the square. We're going to start off by looking at, well, why do we need to complete the square? What does it even mean? What does this complete square form look like? Then we're going to complete the square. We're going to look at examples where the coefficient of x is positive, negative, and odd. Then we're going to move on to looking at, well, what happens when the coefficient of x squared has a value which is not 1. Then we're going to look at, well, how do you use that to solve a quadratic? And then we're going to look at, well, what is a turning point and how do you find the turning point by completing the square? How do you sketch a graph given that you found the turning point and the intercepts? And then how do you work backwards? So if you've been given a set of turning points, how can you work backwards to find out what the original quadratic equation was? And then we're going to wrap up, as always, with the real exam questions. And I've picked 2 difficult exam questions for us to look at. That is this one here and that one there. So as with all my videos, I'm going to do the example on the left, which is I do. You are then going to press pause and have a go at the example on the right, which is you do. And the bottom of the slide tells us the first example we're looking at is where the coefficient of x is positive. So this is a typical question you get in the exam. Express the following in the completed square form. So this is what the completed square form is. And we need to express that in the completed square form. So when you do complete the square, just for a bit of context, what you'd find is if a graph looks like this, it allows you to find the turning point, and the turning point is that point there. So if someone tells you why you're completing the square, your answer should be so you can sketch a graph with its turning point. So let's make a start on this. So let's write this in that completed square form so we can see it's got brackets. So I'm just looking at that right there. 2 brackets with a squared on the end. We're going to copy the x in. Now for a, we're looking here and we're going to half this value. So we're going to half the 4. So we're going to copy the plus sign. We're going to half the 4, which becomes a 2. Now, if I expand this out, if I just use a different color, that would give me x squared plus 4x plus 4. So you can see this almost looks the same as that bit there, right? But we've got this extra 4. So what we're going to do is we're going to subtract that 4. And now this, if I just use my highlighter, this is exactly the same as that bit there if you expand it out. Okay, and then finally we're left with the minus 1. And now if I tidy that up, I'll end up with x plus 2 squared minus 5. And that is how you complete the square. So this is now written in the completed square form. So press pause and have a go at the example on the right. So again, hopefully follow the same steps. We're going to write the brackets with the squared on the end. We're going to write x. We're going to half this. So that's going to be plus, copy that sign, which is 3. Then we're going to do 3 squared. And we're going to subtract that. So that's the minus 9. And then we're just going to copy the minus 2 down. And now we're going to tidy that up. And that is that done. Now, moving on. We are now going to look at examples where the coefficient of x is negative. So exact same steps again. We're going to write the brackets, x, put the squared on the end. Now we're going to half this value. So that's minus 10. So that's going to become minus 5. And then we're going to do 5 squared, which gives us 25. So we're going to subtract minus 25 and then copy the plus 3 down. So similar to before. And then just tidy that up. And that is that written in the completed square form. Hopefully you've pressed pause and had a go at this one. So write your brackets. So that's x. We're going to half this value. So that's going to be minus 1. Square that. Now, if you square 1, you end up with 1. So we're going to subtract 1 and then add 7. And then that becomes x minus 1 squared plus 6. And that's written in the completed square form. So here are some practice questions for you to have a go at. Press pause and have a go. Here are the answers. Mark your work. Now, moving on. Now we are looking at examples where the coefficient of x is odd. Okay, so we're going to write the brackets as usual. Now you might be tempted here to half the 5 and write it as 2.5. You don't want to write it as a decimal. It's easier to work with a fraction, so we're just going to write 5 over 2 squared. Now if you square the 5 over 2, you end up with 25 over 4, and we copy the 3 down, which is minus 3. Now in order for us to tidy this bit up, the denominator of 3 has got to be 4. So if you do that, so that'll be x plus 5 over 2 squared minus 25 over 4. Now if I multiply the top and bottom by 4, that'll give me 12 over 4. And now I can tidy that up because the denominator is about the same. So that'll be x plus 5 over 2 squared. So that will be 4 at the bottom here, and that's just going to be 37 there. And that is how you complete the square with an odd x coefficient. Again, hopefully you've pressed pause and had a go at the example on the right. So again, write your brackets, half the value, square that value and subtract it. So that's 9 over 4 plus 2. Now again, to tidy this up, we're going to do the exact same. So we are going to multiply the top and bottom of 2 by 4. So that becomes 8 over 4. And now, because the denominators are the same, we can tidy that up. So that's x plus 3 over 2 squared minus 1 over 4. So here are some practice questions for you to have a go at. Press pause and have a go. Here are the answers. Mark your work. Now moving on, now we have expressed the following in the completed square form. Now this one's a bit trickier. And the reason it's a bit trickier is because the coefficient of x squared is not 1. So what we want to do is we want to factorize this bit here. And just to show you that, we're going to take a factor of 2 out. That's x squared plus 2. And we're going to leave the plus 3 as it is. That's not part of the factorization. Now what we've done is we've isolated the x squared. It's now on its own. So we're now going to complete the square on just this bit here. Okay, so if we carry on down, that's going to be 2. Same brackets. Now we're going to complete the square on that bit in there. So that's going to be x plus 1 squared. So we're going to subtract the 1 extra that we end up with, plus 3. Hopefully there's nothing new there. All I've done inside is complete the square. Now we're going to expand this out. So I'm going to multiply the 2 by this, and then we'll multiply the 2 by that. So that then becomes 2 bracket x plus 1 squared minus 2 plus 3. And now we're just going to tidy the last bit up. So that's going to be 2 bracket x plus 1 squared plus 1. And that is that. So again, hopefully you've pressed pause and had a go at the example on the right. Now the coefficient of x squared isn't 1, so we're going to factorize that. So we're just going to look at that bit there. So take the 3 out. That now means the x squared is on its own. So that's x squared plus 3 plus 1. Don't forget the x there. And I did forget the x there, so let's put that back in there. And now we are just going to complete the square on the bit inside. So that's going to be x plus 3 over 2 all squared minus 9 over 4 plus 1. And now we're going to multiply that out. So that's going to be 3 times this thing here and 3 times that. So that is going to be 3 bracket x plus 3 over 2 squared minus 27 over 4 and then plus 1. Now we can tidy this up. So we can just write the plus 1 is this, if you can just multiply the top and bottom by 4. So that can then be written as, so if I just write that here, x plus 3 over 2 all squared minus 27 over 4 plus 4 over 4. And just to tidy that up, so that'll become 3 bracket x plus 3 over 2 all squared minus 23 over 4. So here are some practice questions for you to have a go at. Press pause and have a go. Here are the answers. Mark your work. Now, we've been asked to solve the quadratic. So notice now it's equal to 0. So we are going to do the same step as before. We're going to complete the square. So let me just do that quickly because we've done that enough times now. So x plus half that value, square that. So 3 squared is 9 minus 7. So that's x plus 3 squared minus 16 is equal to 0. Okay, so now to solve this, we're going to move the 16 over to the other side. So that's x plus 3 squared is equal to 16. We are now going to square root both sides to get rid of the square. So that's x plus 3 is equal to square root 16. Now this is where people tend to make a mistake. When you square root a number, you end up with 2 answers, a positive and a negative. So you need the plus and the minus there. And then we can write that as x. We can move the minus 3 over, so that'll be minus 3 plus or minus 4. Now, where does the 4 come from? If you find the square root of 16, that's 4. So now a final answer is actually 2 answers. So you can write x is equal to minus 3 minus 4, which is minus 7, or x is equal to minus 3 plus 4, which is 1. Okay, so our answers for this question are that one there and that one there. You end up with 2 values. So press pause and have a go at the example on the right. So again, start off as usual. You are just completing the square. -4 minus 5 is equal to 0. So that's x plus 2 squared minus 9 is equal to 0. And then we end up with x plus 2 squared is equal to 9. We are going to square root both sides. And remember here, you can end up with 2 possible answers, so plus or minus 9. And then you have x. Move the 2 over. And your final answer is x is equal to -5 or x is equal to 1. So here are some practice questions for you to have a go at. Press pause and have a go. Here are the answers. Now you will need a calculator for B and C, and that's fine. And now, again, the exact same thing, but now we're looking at examples where the coefficient of x squared is not 1. Okay? So again, just like before, we are going to factorize that out. So take the 2 out. So that's x squared minus 2x. Leave the 6 as it is. Now complete the square on the bit inside. -1. Now we are going to expand the brackets. So 2 times that, and then 2 times that. Tidy that up. And move the 8 over. So we can do x minus 1 is equal to 8. And we can move the 2 over at the same time. So divide each side by 2. So that becomes that, which is then equal to 4. So I can just write that as 4. So I've done 2 steps there. I've moved the -8 over, which is a +8, and then I've divided it by 2. And then I can just square root both sides. So that is going to be square root plus or minus 4. So that means x is equal to -1, -2, or -1 plus 2, which becomes -3, and that becomes 1. So those are the 2 possible answers you'd end up with, that one or that one. So again, hopefully you've pressed pause and had a go. So similar to before, there's a 5 in front of the x squared. So we want to get rid of that. So we can factorize just this bit here. And that means we have 5 square brackets. We have x squared minus 4x minus 4. Now we are going to complete the square on the bit inside. So that's 5 bracket x minus 2 all squared minus 4. And now we are going to expand the brackets out. So that's going to be 5 times that, and then 5 times that. Now we are going to tidy that up. So, well, actually, I'll just tidy it up right here. So that will become -24. And then moving on, we have x minus 2 squared is equal to 24 over 5. And then we have x is equal to the square root of 24 over 5 plus or minus. And then x is equal to 2 plus or minus the square root of 24 over 5. And in this case, again, you can use your calculator, of course, and that would give us the positive answer to, what does it say, 2 decimal places of 4.19. Or if I just grab my calculator, and the other one is going to be -0.19. So here are some practice questions for you to have a go at. Press pause and have a go. Here are the answers. Mark your work. Moving on. So we are now looking at example where write down the coordinate for the turning point. So when you do complete the square, so in this example, you can see they've completed the square for us, which is fine. And they're asking us to find the turning point. So just for a bit of context, if you have a graph here, now a turning point of a quadratic is that point there, the point at which it turns. Now that is when the value of y is as small as possible. So in order for us to make the value of y as small as possible, we have to make this bit 0. Well, the reason we have to make this bit 0 is because the smallest value, x, can be or the square of a number can be is 0. So if I was to make this bit 0, we can say that x, let me just change my color. We can say x is equal to 5. So when x is equal to 5, this becomes 0, so that goes, and we're left with y is equal to 2. So that is the coordinates of the turning point. So you make that bit in the squared as small as possible. Now the smallest square number is 0, so we made that 0 by making x 5, and then you're left with 2. So again, the same principle applies here. Make this bit as the squared bit as small as possible, which means it's going to be 0. So to make that 0, x must equal to minus 2. That means that becomes 0, and you're left with y is equal to minus 7, and that is the turning point. So here are some practice questions you need to have a go at, and here are the answers. Now moving on, now it says, sketch a graph of the following showing the coordinates of the turning point and the exact coordinates of any intercepts with the x-axis. No, not the x-axis, it just says with the axis. Okay, cool. So now with graphs, there can be a few points of intercept. So again, just to quickly sketch something out. So with a graph like this, for example, there's only one point of intercept, which is that one there with the axis. Okay, and the only other point we need to sketch this graph really is the turning point. Now, with a graph like, if I draw it out down here, with a graph like this, there are multiple points of intercept. So there is one y-intercept, which there always is, and there's also two x-intercepts. So if I just rub this off for now, so just to bear that in mind. So with this example, we are only going to be looking at finding the intercept on the y-axis, and you'll find out why soon. So there's two bits to this. So let's start with finding the turning point. So to find the turning point, we're going to complete the square. So now to find the point, the turning point here, all we have to do is make the squared bit as small as possible. So that means x is equal to minus 2, and y is equal, well, I shouldn't really write 0. We can just write that is equal to y, and then y is equal to 1. So that is the coordinates of the turning point. Okay, so that's the turning point there done. Now, if I was to draw, it does ask for a sketch as well. So if I just draw a little graph down here, so we can say that the turning point is at x is equal to minus 2, y is equal to 1. So the turning point is roughly there. Okay, and we can label that on. So minus 2, and that is 1. And now that's not enough for us to sketch the graph. We also need the intercept. So in this case, we can find, since x is positive, we know the graph is going to look something like this. So we can find the y-intercept. So we know this graph is going to have no x-intercepts in this case. So to find the y-intercept, you have to make x 0. So we write the equation out, x squared plus 4x plus 5. Now if x was 0, we end up with y is equal to 0 plus 4 times 0 plus 5. And that just becomes, well, y is equal to 5. So when x is 0, y is 5. Now that is a y-intercept. So we can plot that on as well. So that is x is 0, y is 5. That goes roughly there. Okay, and now I can just draw my little sketch for this. So that would look something like that. So there's two pieces of information we needed. A was the turning point, which we found by completing the square, and B was the y-intercept. So if we move over to the graph on the right, so hopefully you've pressed pause and had a go at this. So step 1, find the turning point. So x plus 5 squared minus 25 plus 30. So that becomes x plus 5 squared minus, no, well, plus 5 is equal to y. Now, so the TP, let's just say that's the turning point. So that would be x is equal to minus 5, y is equal to 5. So that's my turning point. I can plot that on the graph. So if I quickly draw a rough sketch for the graph. So that is x is minus 5, y is 5. So that's my turning point done. And just looking at this, we know because x squared, this is key, right? Because x squared is positive, we know the graph looks something like this. So because the graph looks something like that, we know it's not going to have any x intercepts, because it's going to look something like this. We just don't know where it's going to cross the y-axis, so it's never going to cross the x-axis. So that's why we only need to worry about finding the y-axis. So if I go down here and we go y, intercept, this is nice and easy. Just make x 0, so y is equal to 0 plus 10 times 0 plus 30. So I can see that when x is 0, y is 30. So that's so let's say that's there. There we go. And if we just draw a little line on, oh, that was going a bit then. And with these points, you do want to label them in the exam. So just to be clear on that. So here you'd want to write the coordinates. You can get away with just labeling the axis as well, but it's better to, although often the wrong way around, there we go. You do want to label them on like this. So even if you don't write the axis coordinates like that, just put 0, 30, there we go. It's just nice and clear to the examiner. So here are some practice questions for you to have a go at. Press pause and have a go. Here are the answers. Mark your work. And now we have intercepts in both the x and y axis. Now, well, part of it is because I've just told you that. And B is, well, we'll find out how we know whether there's intercepts in the y and the x axis. So if you go ahead and just start with finding the turning point. So normally you need the turning point and the y-intercept, and you only need the x-intercept if the graph crosses the x-intercept. So if we start off with the turning point, that'll be x plus 2 squared minus 4 plus 3, and that's x plus 2 squared minus 1. So the turning point coordinates are x is minus 2, y is equal to minus 1. So that's a turning point done. So with the y-intercept, this one's nice and easy. All you do is substitute x is 0 into the equation. So that's going to be 0 plus 4 times 0 plus 3. So that means when y is 3, oh, well, x is 0, y is 3. So we've got these 2 points. So if you look at our graph for now, so if we just get this going, that there, and that there, awesome. So if you plot the turning point first, you'd realize the turning point is now down here. And if I plot on the y-intercept, so again, I'll write the coordinates, x is 0, y is 3. Now you can straight away see that this graph is going to cross. I'm going to rub this line out, but just to show you give you a rough idea. You can see the graph looks something like this, and it is going to cross the x-axis there and there somewhere. We need the coordinates of that for this question, right? Just to show that we've actually drawn this. So because it's going to cross the x-intercept, we're going to write down here, we can do the exact same thing. So we're going to say x-intercept. Now, the x-intercept happens when the value of y is 0. Now, because we've already completed the square, we can use what we found here. So if I bring that down here, all we're saying is, well, y is equal to x plus 2 squared minus 1. So when it crosses the x-axis, y must be 0. So all we're now saying is, well, 0 is equal to x plus 2 squared minus 1. If I rearrange this, we end up with square root of 1 is equal to x plus 2, and then we end up with, well, the square root of 1 is just 1, so we end up with x is equal to plus or minus 1 minus 2. So that means when y is 0, x is equal to minus 3, or when y is 0, x is equal to minus 1. And we can just label that on, so that will be minus 1, 0, and that would be minus 3, 0. So again, hopefully you've pressed pause now to go at the example on the right. Step 1, find the turning point. And once you've got the turning point, it'll give you an idea of whether it crosses the x-axis or not. Minus 5 squared. And straight away, it can come down here. Awesome. And we can see the turning point coordinates. You've got the turning point coordinates now, so we can see that's in the lower left quadrant, so that's going to cross the x-axis. And if I do the y-intercept, because it's nice and easy, all you have to do is make x 0, so that means y is 0 plus 10 times 0 plus 24, so I can see that when x is 0, y is 24, and then finally the x-intercept. Now for the x-intercept, we're just going to copy the completed square that we've done there. We're going to copy that down here. We're going to say, well, y is equal to x plus 5 squared minus 1. We just make y equal to 0. So that's x plus 5 squared minus 1. Move the 1 over, so that's going to be square root of plus or minus 1 is equal to x plus 5, which means that x is equal to plus or minus 1, because the square root of 1 is just 1, minus 5. So that means x is equal to minus 6 when y is 0, or x is equal to minus 4 when y is 0. So that is all of our points done now, and we just plot the graph for that. Awesome. And we are going to put the points on. So 0, 24. So that is 0, 24 there. And then we have minus 5, minus 1. So we can drop that there. And then we have minus 4 there. And it's just a rough sketch, so we're not being 100% accurate here. But I highly recommend that you do label all of the points so it's clear to the examiner that you know you've put everything where it goes. So that's minus 4, 0. That is minus 6, 0. And then that is minus 5, minus 1. So here are some practice questions for you to have a go at. Press pause and have a go. Here are the answers. Mark your work. And now we have find the turning point. For the following turning points, find the value of A and B in that graph. So now we're working backwards. We've been given the turning point. Now, with this, you've got to think backwards. So remember, the equation looked something in this form. So you end up with something that looks like x is there, there's a squared there. And now the value on the end is that bit there. So since it's plus 4 here, we'll just copy the plus 4. So that's how you have to think backwards on how was it that we were getting the coordinates in the first place. And then this value must be minus 1. Now I'll let you think about that for a second. So if you have been given this, how do you find the turning point? Well, remember we said we're going to make this bit as small as possible, and the smallest a squared value can be 0, which meant that x was going to be 1. And then you're left with, well, if that's 0, y is equal to 4. So you can see we've ended up with that there. So if you look at the example on the right, in a similar manner, we have y is equal to, so we get the squared brackets. Now what goes on the end is that value there. So since it's positive, that's a plus 2. And the bit inside, well, what they're telling us is, well, minus 5 is what was used to make the value 0. So that means this must have been plus 5, because if you put minus 5 in there, that made it 0. So you're just working backwards. So press pause and have a go at these examples. When you're ready, press play for the answers. Here are the answers. Now, up next, we have this example here. Actually, just going back, I've just realized I've made a mistake here. So once you do end up in this form, you do need to expand this out. So once you end up with that form there, which is y is equal to x minus 1 squared plus 4, the question wants it in that form there with a and b. So we expand this out. So that's y is equal to x squared minus 2x plus 2 plus 4. And then tidy that up. So you have x squared minus 2x plus 6. And then from there, you can see a, which is that value there, is minus 2, and b, which is that value there, is 6. And then again, hopefully you've pressed pause and had a go at the example on this side. So that's then just going to become x squared plus 10x plus 25 plus 2. Tidying that up. And now comparing this to that up there. So we can see that a is equal to 10 and b is equal to 27. And now we're going to look at some hard exam questions. There's 2 that we're going to look at. So in this one, I'll let you read the question and have a go at it yourself first if you want. So we've been given the equation of a curve. It has 1 turning point. So it says by completing the square, show that those are the coordinates. So we're just going to complete the square on this. So remember, with completing the square, what's the problem with this one? Straight away, I can see that the coefficient of x squared is not 1. So that's the first thing that I want to do, just factor the 4 out. So now I just want to complete the square on the bit inside. And now I just want to expand that out. And there we go. So we can see that the turning point for this would have been, well, we want to make, we want the minimum value of y. So we want to make this bit as small as you can. So to make this as small as you can, that would be making the squared bit 0. So that means x is equal to 7. And that then leaves us with y as minus 196. And that is that done. Now looking at this one here. So again, feel free to press pause and have a go at this yourself before I go through it. So we've been given a curve with 2 points. They're not turning points, it just says the points lie on the curve. And we can see that those points are referring to that there and that there. They're referring to the points on the x-axis because the value of, actually they're not. So 0 minus 5 is that one there. And the second one is, just read that off. Let me just read that again. Equation. Yep. The point 0 minus 5. So that's that one there. And then it says when y is, and that one there. Right. So those are the points we've been given. Awesome. So if I just look at this with the first one, so we have y is equal to x squared plus ax plus b. If I look at the first coordinate we've been given, I'm just going to substitute that into the equation above. So I can see that this is the x value and this is the y value. So if I just go with the y value first, minus 5 is equal to x, which is 0, plus ax, which is a times 0, plus b. If I tidy that up, that becomes 5. So that's 0, b. So we now have the value of b. If I now look at the second coordinate, which is 5, 0. Again, this is the x value and that's the y value. If I substitute it into the same equation, so that gives me 0 is equal to 5 squared plus 5a plus b. Now I know what the value of b is because I've just figured it out there. So I can just substitute that in. So that gives me 0 is equal to 25, which is 5 squared plus 5a minus 5. If I tidy that up, and now if I rearrange that, and now if I divide each side by 5, now what is, find the coordinates of the turning point of the curve. So we can now say that y is equal to x squared plus, or not plus, minus 4x minus 5. If I complete the square, I can use that to find the turning points. So if I rearrange this, well, not rearrange it, that is that done. So to find the turning points, we need the minimum value of y, which means I want to make this x squared value as small as possible. So that means x is going to be 2, and then y is going to be minus 9. And that is the end of this video. Thank you so much for watching. If you found this useful, do check out my channel.